Hello, we are Team 7 and we did a project about creating handwriting fonts using machine learning. This is our presentation index. A few years ago in a drama called Startup, there was a content related to machine learning algorithm using handwriting data and our team members watched it impressively. So we decided to use handwriting data for machine learning and we finally decided to make fonts using it. When we searched in internet, there was an internet service that makes font with customers' handwriting called Ongulip. When we looked at the production progress in Onglip, there was a template designed by itself and about 200 Korean characters, 100 English symbols, and several other sentences were needed. Therefore, based on this, we decided to create a machine learning algorithm that can produce fonts for each handwriting with few samples as possible. However, there was a limitation in trying to improve the actual code, so we changed our objective to compare and analyze handwriting-based font generation algorithm using GAN structure and unit structure using GAN and suggest the direction of the algorithm. First, we tried filtering to print the image more neatly. It is expected the noise can be reduced by using for a fine contours function of OpenCV because it can detect the outline. We can also use reduced noise by drawing a rectangle through bounding rect function of OpenCV to distinguish numbers. In addition, we wanted to add a task of erasing the background and binarizing the value taken in the camera pictured image to make it as data. This was also attempted using OpenCV, but it was difficult to make them compatible with the existing code, and it took several additional algorithms to make it possible to recognize handwritten data taken with photos. In addition, even if it succeeded in improving some of the code through many trials, this did not make a significant difference. Therefore, the following analysis attempts to analyze the main ideas of existing codes. GEN model is made by transfer learning from pre-learning model. In the pre-learning model, we learned how to restore letters from these vectors after extracting and vectorizing the characteristics of the character images. The first step is to learn from the beginning and learn 30 epochs and using L1 loss. Step 2 learns 120 epochs using constant loss. The reason for dividing in this way is the characteristics of each loss. In the case of generators using L loss, instead of focusing on the details, they tend to roughly represent the overall shape. In the case of generators using constant loss, there is a tendency to be advantageous in making the details clear. With this difference, the efficiency of the algorithm was increased by determining when to use the appropriate loss. This picture is GAN model that created font images after learning handwriting data. There are several more analysis and they make quite efficient GAN model. However, using GAN model, it requires 50 hours. Because it takes a long time, we needed to improve it. This is the result image. Left one is created by GAN model and the right one is handwriting. We found and analyzed the code written in the GAN structure, but we tried to write the code in an easier structure with the things that we've learned. Therefore, we tried to write code through UNet using CNN. In encoder and decoder, several convolutional layers were applied to form a UNet structure. Several layers applied with ReLU, convolution, batch normalization were applied to recognize handwriting by using UNet to classify and recognize handwriting. However, after recognition, there have been many difficulties in progressing the image in the part of generating the image. From grasping the shape of the image, there was a problem with the unit code and the noise of the generated image was too severe. The code containing unit consists of encoders and decoders that vectorize and recover images with categories and discriminators that compete with each other to generate images, just like the code used only by the GAN structure. A decode layer consists of convolution, batch normalization, dropout of 50%, and ReLU. For sophisticated analysis, one more layer is added in decoder, and the decoder consists of total 8 layers to create a skip connection which can be judged to make the segmentation of the computer, recognizing letters a little more sophisticated to produce similar characters. The problems solved in the previous stage of generation by using UNet are as follows. Generated images less appear blurred after using skip connection, and recognition is improved accurately in specially styled phones such as handwriting. In addition, the learning time of existing GAN has reduced a lot, and the analysis was easier. We were able to draw three conclusions through comparative analysis. First, in the case of UNet using GEN, the execution time was reduced by about 30 hours compared to GEN. In terms of execution time, it was found that the case of using the UNet structure was superior. Second, UNet used data augmentation to show superior performance with less learning data, which does not show much difference in the amount of data, as the idea is so grafted on the GEN code used in the analysis. However, if it were GEN using without data augmentation, the GEN plus UNet algorithm would have been superior in terms of datasets. Third, in order to learn the handwriting-based font generation project faster and more accurately, I think it would be good to apply a structure such as the residual UNet, which has developed from UNet. GEN is famous for its difficulty to learn because it has an unstable structure that requires solving set of problems in min-max. Therefore, a well-designed loss function should be set. Analysis shows that we have produced good quality results using a well-designed loss function, but we do not solve the fundamental GEN structure problem. So it would be good to use DCGEN to solve the problem. Finally, we think it would be a better algorithm if the cleansing work are improved, which we attempted to improve but failed to produce meaningful results. Thanks for listening to our presentation.